Okay, welcome back. So this is the final session of the Egeria Dojo Live. And we're going to cover some of the history and the design principles that have been embedded into Egeria, and that may help you understand the technology a little bit better. So many of you know that Egeria has had a long history leading to the point where we wrote our first line of code. And it actually came from a long-term collaboration between ING and IBM around their major data transformation that they were doing. In fact, it was an entire cultural transformation of their organization to become data-driven. And we started with the idea of a data lake to allow data sharing across a bank. And banks are highly regulated, and so data sharing has to be done with extreme care. But they wanted to break down their current operational silos to be much more customer centric. And so the data lake architecture that was the foundation of this work started to pull out different principles around the design for a data lake. And obviously ING was working with IBM at the time, and we were using IBM technology to actually create this consistent service. And it meant that a lot of IBM technology had to be changed to be integrated. And the integration was not these technologies calling one another, but it was to get the metadata integration complete. So basically that they were sharing knowledge about data. They were all working off of the same type of definitions. And so we started to get this working in an IBM context, but ING weren't satisfied with that quite rightly, because they wanted to use Spark and Scoop and products from other vendors. And this design cut them out. And so IBM opened up all their APIs and said, you know, anybody can use them, they're fully open, but that is not the same, right? No vendor is other vendor is going to integrate with us, because there are, you know, who do they integrate with? And that was really where we thought, wait a minute, this isn't working. We need to think differently. The other thing the data lake architecture gave us was an awful lot of detail about the types of APIs. So you see all these little arrows across here. These are all different APIs. And we found that actually there were many gaps in the market that this exposed. And often it was because you could very easily build an API, UI, and a metadata repository behind it that could serve these purposes. But how do you fill it? How do you fill that repository with metadata? Because all that knowledge is coming from something completely different. And that was where the discussion started to happen. It was, we have to become multi-vendor, you know, fully embrace the open source projects as well. And we need to start filling the gaps in provision for an organization that wants to build even a data lake, but, you know, to even move beyond that and become data driven. So that was really where the discussions happened. And we spent over a year talking about a hypothetical open metadata capability. It wasn't called Egeria at that time, it was called open metadata. And actually talking about how this should work. And this is where the principles came from. They are a lot about the fact that there are a lot of people involved. And so there's two aspects to that. This is complex, so we want the system to look after itself and not require a large, extensive team just focusing on keeping Egeria running. So we've got this focus on it should be as self-configuring as possible. We default as much as we can. We don't expect lots of different configuration files to be consistent and lined up. We try to do the minimum. And I'll take you through how the cohort works, and that'll show you an example of how the cohort is self-configuring. We've got a lot of validation checks, because if we're bringing technology from different stables effectively together, we don't want metadata to become corrupted because because different products are misinterpreting the standards or storing things differently. So there's a lot of validation around the exchange that they're all still agreeing and talking the same language. And then there's also the placement of metadata. I'll talk a little bit about that, which actually optimizes how and where metadata is being retrieved from. So that's sort of how do we make the ecosystem as easy to run and and then to move any opportunities for errors. The next is to allow automation both in the operations environment but also in the broader data ecosystem. We will need to be highly integratable because we want to be inclusive of all the different vendors and different technologies. So making it easy for people to take our technology and embed it, but also to plug in lots of third parties. So this is another big focus of the platform. And in line with that, in order to embrace as much of the landscape as possible, we need to be very extensible. So things like the type definitions are extendable by anybody. We use a lot of configuration to define behavior. So it's very easy to change what's going on in a platform, new servers, etc., because they're all driven by configuration. And another part of that is for it to be able to run in a multi-tenant environment, to work in different types of containers, as well as work natively on a machine or any type of VM. So that area is also extremely important. That's the sort of technology side. The next piece is really about building up trust in getting the community to trust us, or trust the technology, trust the project. So from a technology point of view, we try very hard to make this a fair ecosystem. So it doesn't matter whether you're a large vendor or a small vendor, you have equal weight in the cohort. Typically you share metadata before you consume, and there is no central repository that everybody has to put their metadata into. Each technology maintains their current metadata repository, and then they have an adapter that allows them to talk open metadata. And the choice of what is shared and what is consumed is with the is locally retained within the particular member or participant in the ecosystem. And so this is again trying to reduce the threat, the feeling that Egeria is taking over, because it's trying to be helpful rather than controlling. We also focused a lot on making sure when you look at different products, how does a product that's focused on quality plug in? How does a metadata discovery product plug in? How does something that's providing value add on top of a lineage, for example, how any of these tools can fit into the ecosystem? We want to make sure that we're not killing the metadata and governance market, that we actually are enhancing it. And so part of that is a conformance mark with the test cases being publicly available. Anyone can run it. And that means that any vendor, whatever their size, can demonstrate and be recognized as compliant with Egeria. So that's a fair ecosystem. Trustworthiness is also embedded in the platform. So every piece of metadata has provenance in it. So we know where it came from, who owns it, and the protocol ensures integrity by only allowing the originator of the metadata to change it. So we will route upgrade requests to the right place. So there's always one place that's controlling the latest version, and then that's distributed. And that way we don't get update conflicts in the ecosystem. We also focus very much on the secure platform and securing instances of metadata. Because knowledge about some assets, some data sets, even knowing the data set exists tells you something. And so who can see what in the metadata ecosystem is an important part of our trustworthiness. Inclusive, this is not just inclusive of organizations and people. We also are very inclusive in our design on technology. So there are options for integrating for somewhat unsophisticated technology, but we don't then take everything to the lowest common denominator. We actually support the highest standards, the best capability that organizations need, and then compensate for technologies that aren't as good. So for example, we might prefer to integrate through listening to events from a particular third-party technology, but if the technology doesn't publish events, we will poll its API. So we will make sure that the architecture will always take advantage of any capability that a third-party technology has, but we will adapt if it doesn't have what we consider, the most optimal way of integrating. And the other thing is that simple systems should be simple, but this is a complex problem that we're solving. And so the complexity of Egeria will only expand in line with the complexity of the problem that it's addressing. So I call that proportionate complexity. And back to the broad applicability, that again is not just on the technology, but also in the breadth of the metadata that we deal with. That's inclusive. And then innovative, I mean, basically many products are limited by the market that they're in. And that market determines what type of metadata they deal with, what type of people they sell to. We ignore all of those market boundaries when we're working with Egeria, and it's all about use cases and need, and if we need to bring in technology from different markets in order to solve that problem, we do that and integrate it. So we're integrating across different life cycles, different types of tools, different types of professionals that are involved. So we don't allow that, we don't allow existing boundaries to get in our way, and that creates innovation. So before, metadata was scoped by the tools, and that tended to scope it to communities. And we're coming along and allowing that to be in this big virtual enterprise graph of metadata. So we need to rethink about how we scope what people see so they're not confused, but also preventing them from seeing things that they shouldn't see. And so we have this idea of governance zones that provide a very flexible way of managing the visibility of metadata. We've also done experimentation, and the architecture has evolved to make it possible for us to push metadata to third-party technology and actually manage and keep it up to date. So it's not just about going and gathering metadata and storing it and presenting it to various users. It's actually about then taking that metadata and making good use of it, so it drives the environment. And also people, so thinking about how individuals, irrespective of their role, would interact with our ecosystem. And then finally, being educational. So there's a lot of misconceptions about governance. There's very, very few practitioners who seriously know how to do this. And so Egeria is aiming to demonstrate and teach best practices, teach the use of standards, enable the use of standards, and ensure that there's plenty of pre-canned content so that an organization that's new to this space can start to evolve the processes and practices and technical capabilities that they need for their organization. So we're trying to bring people together, raise what they can do, and sort of improve their entire ecosystem when it comes to metadata. And that's always the way with governance technology. It's always people, process, technology. Unless you do all three together, you don't actually have a big effect. So that's why we have that breadth of thought. But all of those things then play into the technology itself. So I'm going to pause there because I've said a lot, and the next section is to go through each one and show you some examples, but I wanted to give you a chance to ask me any questions about something I've said at this point. I will share the link to the PowerPoint when I've made it shareable, but yes, it will go into the Dojo material, but definitely this will be available. I'll take that as a compliment. Okay, so let's start talking about what it means to be autonomic for a start. So when on Wikipedia, there's a really good page on what it means to be autonomic, and this is about getting systems that are self-managing and basically that you can leave on their own, and no matter what happens, it sorts itself out. So it's an operational intelligence that we're thinking of here, and the areas that we've particularly focused on are self-configuring, and it's not that there's no configuring in Egeria, but what we try to do is to keep the configuration local and keep the decisions that are being made within that configuration to be about the services that the local community want, and that determines how they integrate with the ecosystem, and then the ecosystem takes over. So we're trying to keep decision making around configuration very local. And then, as I say, the broader ecosystem comes together. And so this picture you see quite often, but the important point is that self-configuring is peer-to-peer as well. So there's no central configuration. The configuration is local to each box, and the cohort is flat. So you know, everybody who's on the cohort has that consistent view, and as I say, they choose what they share, they choose what they consume, and we can build out. You know, it's possible for a single system to choose to join multiple cohorts, and then they see the superset of all the things. So the way that's working under the covers is that when a system comes up and they're told to connect to a cohort, what they're given is the address of a topic. And by default we use Kafka, but it doesn't have to be. You can change the event bus, the event mechanism, as long as you do it consistently across the cohort, it works fine. And what happens is the server puts information about itself. So it sort of publishes it and says, hey, I'm a metadata repository, please talk to me, and that's that registration, and then that's it. It's done. And another server comes along and puts out their registration message. So we've got a pink and a blue server now, and they then have a little exchange, and basically the server one will the pink server will post another registration just to make sure that it's got the latest date. And once they're both happy, then they do an exchange of their type systems to make sure there's no incompatibilities. They don't have to support all of each other's types. They just, where there's an overlap, they must be consistent. That's the rules. And so at that stage, we know that they know about each other, and they know that they're consistent, and it's then possible for each to call the other, because in that registration information is the URL of the server. So now we've got federated queries effectively enabled between these two servers. So if you're connecting to the pink server, when you issue a query, you're going to get a combination of pink and blue, and similarly on the blue side. And we could leave it at that and always do federated queries. But of course, some servers are not as performant as others. Some servers are not available all the time. And there's a lot of metadata that's very slowly changing. And in fact, it's created and then never changed. So we also support behind the scenes the ability, we support notifications. So whenever anything updates or is created or is deleted, there are events going across to say, oh, by the way, this has changed. And that means that each server can react to things happening in another server, and they can also keep a cache copy of that metadata. Now, at any update, so if a pink server, somebody in a pink server tries to update the blue metadata, that request is routed to the blue server. So the blue server is the only one who can make updates, but it can be initiated from the pink server. And so this ecosystem then can grow and sort of self-optimize as well. So the way the self-optimization works is that as, for example, the pink users request metadata from the blue server, server one is constantly checking, oh, have I got a copy of that? Have I got a copy of that? And is it useful? And so the server one is also firstly it's listening for updates, but of course if it joins after server 2 is filled up, it'll never see messages for the metadata that's not changing. So the replication is one mechanism, but the other is it's constantly monitoring what the users are asking for, and if it comes across metadata it doesn't know about, but it's also being queried frequently, it will then make a request for server 2. It's called a refresh request that will ask for the instances that seem to be of interest to the user. And the reason we don't just take the one that came back to the user is that the user, the content might be redacted because of the specific user. So by asking the server through the OMAS topic for a refresh of a particular instance, it will mean that the cache inside server 1 will build up with metadata that's relevant and complete, but relevant to the users at its site, not contain every piece of metadata that's ever existed. So that's what we mean by the optimization that's going on inside the cohort. So let me pause there. Does that make sense? Okay, I will keep going. Yes, I got yes. Excellent, thank you. When we look at a particular object inside open metadata, what you'll see is there's type information that's passed with every instance, and we're using that to validate that there's nothing horrible gone wrong. Like each has got a definition of the type database, but they are different things. And so the meaning of particular values could be incorrect. So we do a lot of validation around the type, and we make sure that the properties associated with the instance match the definition and the type. Makes sense? You can also see this control information here. I don't know how easy it is to read, but the control information is really telling us where this thing has come from, which is, and you can see what version we're on. So versioning is absolutely critical in a distributed environment. And we're saying that this has come from the local cohort. And this number here, the metadata collection ID, is the identifier of the server where that came from. And that's what we use to route the update requests to. So that's what that's for. So it looks like these objects are quite big, but a lot of what's in there is to give us assurance that there is integrity in the exchange, and the ability that when something goes wrong, I always say when rather than if, I hope it's never, but when something goes wrong, it's generally caused by an operational error, but you have to find a way to allow people to correct things. And so this type and control information is critical to allow us to do that. So my front door's ringing, but I think we'll have to just keep going. Yeah, so that's where we are with that. We have a similar thing going on in the event design. You can see there are 3 types of events. First, the registry event is the one that does.
Did you want to take your front door? It's okay, I can pause and you can go.
Okay, all right, give me a second, thank you. Okay, so we see this autonomic design again in the event design, because there are control sections. We can see where things are coming from. We also have the 3 types of events. The registry events are for that registration process. The type def events are for that validation, are all the types consistent in the cohort, and the instance events are the ones for the replication and the refresh processing that's going on. The other thing that happens, I'm slightly out of breath, is that there are very detailed error messages in when any member discovers something that doesn't look right. It's broadcast to all the others, and then they will immediately start looking at their perspective and whether they think the originator is wrong or the person reporting the error. So there's very active management of errors as that goes on. Right, so so that's the events. And then finally, the federated query. This enterprise OMAS connector, sort of mouthful, that is the component that does the federated query. So it's the one where you ask it for the metadata and it talks out through all of the members of the cohort. And this is the component that is smart enough to actually do that constant analysis of where metadata is coming from, where to put the requests, and it's talking to its local repository to say, do you want, and the responsibility for refreshing and things is with the local repository. So that's where that function sits. And then the APIs that most of the tools are using is this thing called the REST API or the event-based APIs that are going on. So it's this is the structure to allow us to be autonomic. I'll give it a little pause and talk about automation. Probably, if you've ever heard me talk about metadata, that is absolutely critical that we automate the metadata environment. Humans are rubbish at paperwork, and we however hard we try, we fail to update things and keep track of things. So the more that the system does this for us, the better. And there's different layers and different places where we want to put automation. So one of them is in the operational space. And so we have an audit log framework, which is underneath everything that's going on. Real focus on the way that we capture exceptions and messages and different types of messages from the ecosystem. And each message has a lot of information that can be used by some sort of decision engine about the significance, seriousness, or action that needs to be taken when certain situations are detected and reported. So every message has a unique ID. It includes things like the system action, what happened, basically, and the user action, what needs to happen. And there's lots of context information about where that's happening. Because if you imagine you've got a platform and you've got 100 servers running on it, and one of them produces a message, you need to know which server it was. It's not good enough to know the Java VM. You have to know, because that's the platform. You have to know the server. You have to know the component within the server. You have to know which thread it was, what it was doing, what went wrong, and remember, there's lots of third-party technologies plugged into this environment. So the error might not be in Egeria, it might be in a third-party connector. So can we isolate and be absolutely sure where the problem happened? And that's really what the Audit Log Framework's doing. And in the configuration, you can plug in different routers for those audit log destinations. So you can have some types of audit log, you just say, oh, I just need to store it in case anybody asks. Others are, need analysis, so it can look at, have I got enough resources in the system? Is there something I can automate in doing? And the others where I need an operator to look at this should never happen. And wait a minute, we've got metadata integrity issue that's been detected, it needs somebody to look at it because it's such an unexpected event. So in the operational space, the audit log framework is key to enabling systems to be automated, and that's particularly important in cloud-based environments. The next aspect of automation is in the broader ecosystem. So how can Egeria help in that border management? And so if you imagine you've got two metadata repositories talking across one or more cohorts, so that's the Open Metadata Highway, it's our marketing name for it. And we know that we can exchange queries. So it might be we have a metadata repository that's really, it's a catalog effectively. And then we may have another metadata repository that's operationally embedded into an environment like Hadoop. And the characteristics, the technical characteristics of these two repositories are very different. The catalog is all about human access and supporting a large number of different web browsers connecting into it, whereas the operational system is probably not got a UI. It's embedded. It's designed to be fast, horizontally scalable, 24/7 type thing. So it's a very different type of technology. But Egeria allows that exchange as if they were one system. And then the embedded operational metadata repository can then start pushing and pulling metadata from the other technologies that are a part of that operational environment and manage the configuration of these two. And that's because we have these high-level interfaces and we have what are called governance servers that actively manage that push and pull of metadata. So we've done some experiments in terms of automatically configuring data virtualization engines and security tools like Apache Ranger. And I think this next picture shows that experiment that we did. And it was very educational in order to learn about the mechanisms that are needed, not just to make it work in a demo, which is where everything starts clean and you build it up and hey, look, it works, but actually to make this work in practice, where these systems are coming up and going down at very different times. And so we need to support the notion that anyone needs to do a restart and a resync. And that's become an important part of our architecture going forward, is the restartability, the resyncability of this ecosystem. And that's what makes it so much more than just, let's just put an event bus like Kafka and everybody share what they're doing. Egeria is going one step beyond that and allowing each to work out where they are and replay things from a sort of intelligent and assistance type interface for each of these technologies. And so what's happening is that in order to make, what we're trying to do is organize the complexity and manage the complexity of the integration environment by providing APIs to each type of technology that is consistent with their needs. And so we're developing in yellow, these are the major types of server types that we're building. And the integration aspect is coming from this integration daemon. And its behavior, we are learning. So I mean, basically, we're learning all the time about how to simplify and improve this environment. But what's emerging is a very clear definition of the integration daemon. And what we have here, these four, have been independently implemented for different use cases. And we're mining those, and very soon we will have an integration daemon that is the best of all four, with specializations for the different types of technology. So most of the code for those four is going to be merged into the integration daemon, and then a very thin specialization for each of the types will sit underneath. And that's an ongoing thing that we do. We tend to look at a use case, do a very naive implementation of exactly what's needed, and then start broadening our perspective, and then refactor and refactor. And what's happening is that we're, as I say, we're starting to organize the integration space through our OMAG servers. And that is further coming, is also coming out in the way that we connect these together. So we talk about onion rings, really. So there's the cohort. The original design of Egeria was around just getting metadata repositories to talk to one another. And then the governance servers have evolved as we've focused more on the integration piece and realized that you can't just provide a load of APIs and hope. You actually need to have technology that can be added afterwards to a third-party technology that's already deployed and build that integration. But you don't want that integration in the main Egeria runtime. You need it in something that's pluggable and can be deployed close to the third-party technology. And so that's caused the governance server to become a separate entity. And initially, these were literally were separate servers, separate technology platforms. And we start to realize, you know, they're 80% the same. They all need to be started and stopped. They all need to be configured, and there's a large overlap in the configuration content. And so that's why the platform emerged with the virtual metadata repository, with the virtual servers on top. And that's, again, speeded up our ability to create new types of servers, but also created a much simpler environment to operate, because from the operator's perspective, there's just a platform and a set of servers, and those servers are either up or down. Once they're configured, that they are all managed in exactly the same way. And so this evolution of the architecture has removed a lot of complexity from the integration piece. And so the idea of this configuration document has emerged, and what that is a set of instructions that defines the characteristics of a particular server that's required. So it basically identifies which services to activate within that server, and there are certain combinations that create a metadata server, and another set of combinations that create a discovery server, etc., etc. And so this has created that consistency in the operational environment. The last bit is, how on earth do we get automation in the broader ecosystem? And the other part, what we also discovered, is that metadata management is very event driven. And if you remember, so basically, as something happens in one tool, suddenly something else starts to happen in another tool. And that's why when you look at our interfaces, there's always a REST API and an inbound asynchronous API and an outbound asynchronous API. And that's to allow a notification-based interaction as well. And the REST API then also becomes useful for the sort of initial synchronization and resync after restart. So the two, that combination of interactions, we don't just use it inside the cohort, we use it on every API to allow all technologies to have that flexible interaction. Okay, next section, which is about integratability. There's two parts to that. One is we have a consistent plugin framework. It's called the connector framework. And the other is we are we are very, very vigilant about dependencies being introduced into the runtime. So much so that if you put something in that we don't know about, the build doesn't build. So there's been a huge amount of work in this space, because this is vital. If we want Egeria's libraries to be embeddable in lots of different vendor products and third-party technologies, it can't be pulling in lots of obscure things from all over the place that only run on one platform. Always has to be things that are generically usable on different operating systems, different container environments, and that's why we're so fussy. The connector framework is basically, we define an interface called a connector, and it has a set of methods on it that allow us to start, stop, or initialize, start, and stop it. And then particular types of connectors have additional interfaces that relate to their special purpose. So here we've got a connector that's providing data. And so it has a get data method, and it also has information that's related to the connector itself. And you'll see that pairing all the time, the sort of basic connector interface and then the specialist interface that goes through it. And those you'll see connection objects all the way through our configuration, and the connection object defines exactly what the all of the parameters to initialize the connector are. So that means that's how you can swap out technology that we've provided by default and have your own implementation. I can't remember. Oh yes. The other thing that you might notice when you look at the cohort pictures I have is that the blue bit is Egeria, and there might be metadata repositories that just plug in a repository. So Janus Graph, database, whatever. But there's others that have this little sidecar, and this is called a repository proxy. And the repository proxy is for an existing technology that's been deployed, and then we have this little plugin that acts as an adapter, two-way exchange, and it's translating from the red system, the third-party system, into open metadata. And the other members of the cohort I'm not aware that this is a completely different system. The proxy does everything for it to connect through. And the way that the proxies work is that there are two types of connectors, one to wrap the API of the third-party technology, and the other to interpret any events that come out of that system, assuming that it has events. And between the two, they talk to Egeria, so the special APIs on those connectors that allow the event mapper can call the repository connector, and the repository connector can talk to the governance catalog. But there are also interfaces where these components can talk to Egeria, and then Egeria does all of the protocol management out over the open metadata highway, over the connection into the cohort. And so this is information governance catalog. And then actually this is an old picture. So we originally, when we were going to do our Atlas integration, we actually were going to bring Egeria inside Apache Atlas. It's exactly the same libraries, exactly the same connectors, but the Egeria technology is embedded in the runtime. And we haven't actually done that, and the Apache Atlas sort of the integration actually runs as a proxy at the moment. Hopefully over time we'll actually get that final piece to do, but it's a big step for a project or a vendor to actually go to the point where they embed Egeria into their runtime. But the code that you write, the yellow bit, is exactly the same. It's a deployment question as to whether it runs on board the server or as a repository proxy. Pause for breath. Can I see anything? Right. So next one is the integration daemons, and I said that we've actually extracted patterns around how these integration daemons work based on the type of technology and how we call them. So all of the logic around the integration daemon is going to be in common, one single common code base, and then all of the different types, depending on the types of technology that are being integrated, will be very simple, effectively wrappers around connectors. That's actually the difference between each type of integration daemon. So that's actually been a very interesting learning curve. And then finally, everything is everywhere, and it's not just, yes, this is a distributed environment, but they're all different sizes, and they all have different assumptions about what the runtime looks like, how big the environment is, how much memory we can use, what's the availability of it, what's the workload going through. And so as a result, since it's just showing it connected together, our platform is very, very flexible in terms of its ability. So at a high level, we can look at you put your platform into each place, irrespective of what the place is. You configure the yellow dots, which are all the servers, and that's how the integration environment works. Only if you're digging into the configuration or the internal configuration or the way that things are running, do you actually need to know very much more than that. A little pause. Are we all still with me? Okay, excellent, excellent, excellent. Okay, so let's talk about extensibility and adaptability. And some of the divisions I've created are a little bit arbitrary, but I'm hoping you'll see that each reinforces the other. And so when we think about the ability to sit in many different environments, this separation of the server from the platform was a very significant design decision and has created our ability to scale. We can run on a Raspberry Pi. We can also run in a horizontally scaled out cluster of servers controlled by Kubernetes, or we can run it as a single platform with lots of different servers in a multi-tenant mode. So, and that is because of that separation. So it's an extremely powerful model to give us the flexibility to cover that huge ecosystem. The other place where we have extensibility is in the type system. So on one hand, we don't want people randomly redefining how to do a database schema because that's boring basically. And we provide nearly 500 different types of metadata that we think is common. So that everybody, no matter what the vendor, describes a database schema, tables and columns in the same way using the same types. That's the ideal. That's really what's necessary to make that exchange happen. However, that's not going to be enough. There's always going to be specialist environments, specialist industries that are going to want to extend the types. So the type system is extensible and anyone can extend it. If they choose to extend it and keep that private, that's entirely up to them. However, if the open source community then goes and creates a type of the same name, then the hidden private types are going to lose when the server comes up. So they are going to be deemed as conflicting, even if they've been there the longest. And it's because we always load the open types first when the server comes up. And it's deliberate. It's deliberate to say the open types take precedent over anything that's defined privately. So the way to protect yourself is, say you've got a set of types that are only for banking, is to contribute those, and we would have those in the open types. So that's the way the ecosystem is designed to work. You're quite happy, it's quite okay to keep them private, but there's always a risk unless you give it a really silly name, and we probably won't reuse that. But that's the thinking process behind it. And we're hoping that this scope, which is bigger than any one product, will be sufficient for most environments, because that, as I say, increases our ability to share. It is also every single release, which we do every month, is expanding this as we add new use cases, and we get different vendors saying, oh, could you add that property because you've missed it out? And it's like, yep, of course, we'll always add it. And again, with the types, so the work that we did with the Palisade team brought in this CSV file. The Avro file is it brought in the Avro file, I'm sorry. So you can see that the type system is evolving as we add more and more use cases to our portfolio. The other thing I want to show you is what's going on in the inside of the cohort, because when you look at this picture, you can see these linkage between everything. And if you're familiar with something like a UML model, one of the problems we have with UML models is that the relationships are stored as if an object is pointing to another, it has an attribute with a type of the other object. And that means that the type of the other object needs to be defined in that first model. And so what ends up happening is that you end up pulling everything in, because everything that's linked together all has to be defined in a single model, or at least all the types. That is not going to work in a large virtual graph. So one of the very early design decisions we made was that a relationship is a first-class object. And so you always think of entities as first-class objects, but we have relationships as first-class objects. And so here's an entity. We allow, if you remember back to the integrity question, only the originator of an object can update it. However, it might be that that object is coming from a system that's really quite primitive, and there's lots of extra stuff that we need to be able to add on around to govern it. So classification, it might be whether something's confidential or not, simple as that, or it might be a zone, or lots of different things that we would want to augment the original definition. And this is what the classification is. It can be added by any server in the cohort, and it's owned by the server that adds it. And it allows us to augment the entity. The other thing that's first class is the relationship, which has properties and a stub for each of the ends. And this is extremely important to allow new types to be added that are relationships that link two things together that are actually never linked in traditional products. Because that's where the value is. It's this linking, it's this ability to go from, okay, I've got this business service, and which machines is that running on, or what is the sovereignty of the data that's associated with it? That's linking down through lots of different types of tools in order to answer that question. So this first-class relationship is extremely important, and the classifications too. And of course, each one of those has attributes associated with them. And what's going on inside the servers is, if you imagine we've got two entities, one describing a database column in server 1, and the other describing a glossary term or description of a definition of the meaning of a term is what a glossary term is. And they're living in different servers, and they've been created by different users. We might want to create a relationship to say that the data in this column means the description described in the glossary term. And the cohort could create a copy of the glossary term and store the meaning relationship in server 1, as long as server 1 support glossary terms. Or we could go the other way if server 2 supports database columns. But if this relationship is unique and not really supported by either server, we can bring in an Egeria server which can store anything and maintain the relationship in server 3. And it doesn't matter which way we do it. When an application issues a request to one of our interfaces, our OMAS interfaces, the behavior will be identical. You will be able to retrieve the meaning irrespective of where it's stored. So that's the real power of the organization of this type of design, and we also support a simplified version of that, which is where we only store the stubs. We call them entity proxies with the meaning, so we don't even have to have the full definition of the object to be able to store the meaning independently. Now the interesting thing is that we support live metadata in the repository. We also support an archive of metadata. And that structure, two entity proxies and a meaning, can be stored in an archive. So you can actually archive off a meaning. You can store that and recover and make that available. So the value of a first-class relationship and the first-class entities classification is a critical part of our ability to adapt and be inclusive in terms of the systems that we're bringing together. Breath for me. Any questions for anybody, or shall I keep going? The next one is the FAIR ecosystem. And this is as much about people and organizations and as about technology, but it deeply influences it. I was involved in a study with the IBM Academy of Technology in 2007, and we were studying successful ecosystems. So we ignored all the ones that failed, picked on the ones that were monumentally successful. And what emerged, surprisingly, was 5 characteristics that were common across all the successful ecosystems. And when you think about open source projects, this is actually all the things we talk about all the time, which is about creating that open community, enabling engagement, taking care of the IP arguments, making sure that the teams can work, and encouraging a mix of people. So that's what we strive for. This is very, as I say, very consistent with John's comments earlier on about the importance of advocacy over and above the technology. However, this also influenced what we call the Open Metadata Manifesto. And this was one of our very early declarations of what we think Egeria should be. And you can see that we're focusing very much on the business, the vendor's business and how they think about it, which of course influenced so many other things that went on. The other thing is that we wanted vendors to be able to demonstrate that they are part of Egeria and they're compliant and safe to install and use. And that's why we have the conformance program. And you don't have to be a member of the ODPI to be conformant. You just have to run the program and accept the fact that if you put that mark on your product, anybody looking to buy your product is quite within their rights to download the test and run it and insist you run it in the proof of concept. So there's no point in declaring that you can support that mark if you don't if you can't, because you'll be discovered by anybody you try to sell to. And that's critical for, again, this idea of the open ecosystem and fairness across it. There's nothing hidden. Next stage is trustworthiness and what makes you trust things. It's partly that they're there when you need them, but they are very transparent in how they're behaving. And they have the mechanisms that allow you to control who can see what. And this is deeply embedded. It goes right back to that type and control structure with the provenance information. So where did it come from? What versions? Exactly what is this thing? And this helps tremendously with the trustworthiness because we can unpick what happened when things go wrong. The next thing is metadata security. Applications, we're sitting in a Spring Boot environment, and so we can secure our REST APIs, our HTTP requests. That's just part of the overall thing, but it's not enough. We have to be able to check, because we are dealing with a huge range of metadata, that some of which is very, very sensitive. And in fact, metadata can be more sensitive than the data it describes, particularly where it's got profile information of the data content. Or even knowing that the asset exists is important. So we have the ability to plug in connectors that control the security. There's one that goes in the platform, and so this is really focused on administration commands, and then one for each server that controls this picture here. So we challenge on, are you allowed to access this server? Are you allowed to access the specific service you asked for? Are you allowed to access the specific operation? That's actually all done in one call to the connector, and each will be validated. But then when we're saying get asset, give me an asset, there's a next level of challenge that says, firstly, is this asset visible? And I'll talk about the governance zones in a second. And secondly, does this person have permission to see this asset? And which properties within the asset? So actually the connector can also redact content of the asset based on the user and the request that's being asked. So there's very, very fine-grained control. And we can even go down to the metadata repository, and you might get all through all that, and the repository go, no, not allowing that. So you can enforce security at different levels. And for some of our APIs, it's perfectly fine to do it at the server level. For other of our APIs, you need to be the control needs to be very, very fine within actually looking at the data. And it applies to assets and connections. And the ... is that we're envisaging needing to do the same for profiles, which is information about people. Undoubtedly there will be more, probably around rules as well, going forward. So that's the security. The next one is inclusivity. This is an ING picture. This is before they started rationalizing. It doesn't look anything like this now. But we have so much technology. I mean, it's incredible, and we're inventing so much. I mean, it's just not stopping. So inclusivity is around the type, and it's not just about stuff that's modern. Stuff we need to integrate can be 40 years old. So we need to think about the generation of technology as well as the type and its origin. The other thing is that it's not just about building a data catalog. This is about supporting DevOps and developers through the development SDLC lifecycle, the governance program teams and bringing them together and enabling them to collaborate, as well as the technical operations, the analytical operations, and the business operations that are happening. And what links them is metadata, and that's really what Egeria is doing, is without being a centralized control point, it tries to enable that integration across the life cycles as well as across the technology types. What we could have done was had an API with 400 types on it, and you could, with CRUD methods, but that basically would have created an environment where every tool populated that type system differently. And we want to avoid that at all costs because we're trying to enable that sharing. So we have 2 levels of interface. The repository services is the one that deals with those very fine-grained. They do all the integrity checking, the routing, the management of the replication and refreshing, registration. All of that is in the repository services. And it has a very fine-grained API, which for most people is very difficult to use. And then on top of that, we build access services that provide simplified, understandable interfaces for different types of tools in different types of life cycles. So it uses the language of the consumer and works through their use cases. So we use use cases, input from practitioners, our persona definitions, in order to make sure that those APIs are as simple and as practical as possible for each of the technologies that we want to integrate. And it's the implementer of the access services that has to deal with the repository interface. And so as I say, we're managing that complexity from the perspective of a particular consumer. And so just to give you a view, so that's one. What are we looking at here? This is one entity, so one node in the graph. This is the governance program OMAS, which is dealing, in this particular one, it's about appointing, it's dealing with the appointment of governance officers to particular governance posts. So this person is the chief data officer, for example. I think that's what this is about, this one. So that particular piece of JSON is much, much less than that, and it actually represents 3 objects. It's talking about the governance post and the people at either end. So there's descriptions about the person that's assigned to the post, and that's Jules Keeper. And we talk about what the role is, which is the governance officer, and then there's the link between it. And actually, you can see 3 unique identifiers, and those are the 3 objects. So in repository services, that's 3 independent objects. in the governance program interface, it's one, and it's not talking about entities, relationships, and classifications. It's talking about governance officers, governance posts, and people. That's the difference between the two interfaces. The other part of inclusivity is the fact that we do things. We will publish interfaces with narrow implementation to get some to get feedback. Everything we do, we try to make sure that there's plenty of opportunity for people to comment. And if we've done something that is a disaster, then we work to organize it. And that comes into the code organization as well. So when it comes to the implementation, the base piece, things like the repository services, they're very specialist interfaces that need people with particular knowledge of middleware integration patterns and operation. The access services need people who understand a particular group of technology and can map down onto the repository services, and et cetera, et cetera. So there's a place for different types of skills that fit in. And then the integration platform is the place where we have all the pluggable things like the connector implementations and utilities and things, which again is helping people with maybe less detailed technical knowledge of Egeria to get things up and running in their environment. So that's broadening the acceptability of Egeria. It makes it suitable for IT teams that basically don't want to write a lot of code. And then the final layer, the governance solutions, are for businesses to select and use. So they are connecting Egeria to your governance professionals, your data scientists, your business people. And so again, that's like expanding out who else can be involved in Egeria as we build out those governance solutions. So nearly there. Innovative. Now, because we're open source, because we are dealing with a first technology to really do this, obviously we hit new, I'll call them opportunities for innovation, or you could call them gotchas or problems or whatever. And that's meaning that a lot of the things we're doing in Egeria are things that have never been done before. So it's extremely innovative project, which is why I think you had so much enthusiasm from the people working upon it, because there isn't a day when we don't learn something new. It's an environment, it's just so interesting, partly because we work with such a wide variety of people, but we're looking at problems from a very different perspective, and the innovation is required. So I mentioned earlier about these governance zones, and they're very lightweight in their implementation because they're actually a classification that's added to any asset, but they can allow us to control the visibility of assets and things that are attached to them, to a point where we can control how, when people can react to the presence of and absence of particular pieces of metadata. So it's actually proved it's not just about sort of security. It's actually about when something happens, because as you move the assets through the zones, you can actually then trigger off more work as the asset becomes visible to different subsets of users. So this has been amazing. And then the next thing is the work that we've done with, say, the Palisades team to create a completely different perspective on how you secure data, moving as far away from access control lists as possible to a point where not only are you looking at the caller and the definition of the data, you're also looking at the context with which they're asking that request. So this is very experimental. However, what we've done is actually sort of shown that a different way of thinking about security is possible, and it becomes critical when you start to bring huge amounts of data together and want to provide a general data service. The other piece is around the personas. So the personas we use, we have a very small number of technical people involved because we're trying to change our mindset away from building for technical people. And that again is changing the effort. It's altering the effort we put into that autonomic stuff I started with, so that we make this environment as simple as possible to set up and run. And we put control into the hands of a chief researcher rather than the administrator of the platform. And that's the sort of thing that's changed from using personas, the design thinking that is associated with it, just looking at the problem from different people's perspective. And then the other area we've been very innovative in is around how does a person interact with a graph? And there are lots of projects that sort of you do a graph query and it dumps the graph on the screen and you can spread it around and look at it. But Graham and our team has been looking very carefully at how do you have a conversation and use that to build up a graph perspective. And so this is one of the results of that work is this repository explorer that, as I say, allows you to interactively build a report that is a subset of the graph by asking different questions. So that's a really nice piece of work. And the innovation will continue. We can think of new ideas faster than we can code them. So it's just baked into the community. The final section is on education, and it's partly to do with adoption, partly because there's such a desperate need. And this is something that's embedded in the ODPI's, which is our foundation's philosophy, which is it's as important to enable people as to enable the technology. And so we use best practices, we teach best practices, we use standards, we teach about standards, and we try to provide as much content into the ecosystem so that people have starter sets. They're not starting with an empty repository and a sort of good luck, cheery wave type thing. So this is key to what we do as well. And this dojo is part of that. We do a lot of webinars, but we also have a website called the Guidance on Governance, and that's designed to attract governance practitioners, bring them in, getting them thinking about how to think about governance, how to build governance that grows your organization and improves its capability rather than tells it it can't do things. So it becomes more enabling rather than restricting. And then that guidance on governance then links you down onto how you do this in Egeria. So that's the theory behind it. And all of this is, you know, there's bits that's mature and bits that needs work on. So we do a lot of different types of information, and you saw the hands-on labs. Again, this is about the educational aspects of teaching people how to do metadata management, how to use Egeria, how to do governance, and all of that aspects associated with it. And this is one of my scribbles, which is, you know, how do we keep a healthy community? And all these things that we've been talking about, particularly today, is around this this process of education, this process of awareness and community. That's a critical part of what we do. So that's it. Well done to everybody. I don't know, do you have any questions? I'm looking here and I can't see anything in the chat. This is just a little summary of everything we've done. And on the back, there are links to interviews with me talking about Egeria. I think that was 2 years ago, but it's still probably right. And other things. And of course, you've seen plenty of material through the dojo. These charts will be published through the dojo as well. Yeah, basically, any questions?